Electrostatics. Electrostatics deals with the cases in which electric charges are stationary. When the charges are stationary, the electric field set up by them remains static, and hence the name electrostatics. An atom in normal condition is electrically neutral because positive charges, protons, and negative charges, electrons, are equal. If a normal atom, however, accepts negatively charged electrons somehow, then the atom is excess. On the other hand, if electrons are removed somehow from a normal atom, then the atom is said to be positively charged, as now positive charges are in excess compared to electrons. Thus, a negatively charged body contains an excess of electrons, and a positively charged body is deficient in electrons. The net excess or deficiency of electrons in a body is known as charge. There are two types of electrostatic charges: positive charge, that is, protons; negative charge, that is, electrons. When we say that a body is charged, we actually mean that it has an excess of charge, that is, either an excess of electrons or protons. However, it may be noted that charge cannot be created or destroyed, but simply can be transferred from one body to another. And during this transfer, both the bodies are charged, one is positively charged, and the other is negatively charged. The net charge in a closed system is conserved. Since, like charges repel and unlike charges attract, there exists a force between them, which is known as electrostatic force. Now, let's discuss Coulomb's inverse square law. Coulomb's law plays a very important role in electrostatics. It gives the force existing between two electric charges. It states that the force F between 2-point charges, Q1 and Q2, is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Consider 2-point charges, Q1 and Q2, separated by a distance r as shown. Then, as per Coulomb's law, the force is directly proportional to Q1 Q2 by r square. Force equals K Q1 Q2 by r square newtons, where K is the proportionality constant given by K equals 1 by 4 pi epsilon. Therefore, force F equals 1 by 4 pi epsilon multiplied by Q1 Q2 by r square newtons, where epsilon equals epsilon naught multiplied by epsilon r. Epsilon is the permittivity or dielectric constant of the medium in which the two charges, Q1 and Q2, are situated. Epsilon naught equals 8.85 times 10 to the power minus 12 F by m, which is the absolute permittivity. Epsilon r, on the other hand, is the relative permittivity of the medium, and epsilon r equals 1 for space or vacuum.